In this lesson, we're going to go over solving quadratic equations, part 2. Specifically, we'll solve quadratic equations by factoring and we'll find the roots of a product of polynomials. As a reminder, quadratic equations come in the form of ax squared plus bx plus c equals 0. To solve these equations by factoring, the right-hand side, or the left, whatever it is, has to be set equal to 0. In the standard form again, a is always in front of x squared, b is always in front of x, and c is always the constant. To get started, solve for x. So recall that we need this to be in the form of ax squared plus bx plus c equal to 0. So we need our equation set equal to 0, meaning one of these terms, the x squared or the 20x, needs to move. I recommend, whenever possible, keeping x squared positive. So in this case, I would move the 20x to the other side. So we'd have x squared minus 20x equals 0. Recall, when factoring, the first step is to always look for a greatest common factor. Between x squared and 20x, our greatest common factor is x. So we'll take out an x from both, and we're left with x squared divided by x is just x, and 20x divided by x is minus 20, and it is still equal to 0. Notice we have linear, or x to power 1 factors, so we can set each of these, x and x minus 20, equal to 0. So when we have x equals 0, x minus 20 equals 0, okay, and we add 20 to both sides, our two answers then are 0 and 20. Typically with these problems, because x is squared, we're looking for two answers. There are cases where there's one answer, which we'll cover later, and there are cases where there's no real solution, which I believe you'll do in the next math class. Example 2, 3x squared equals 5x plus 2. Again, we want our equation to be set equal to 0, so we can solve this by factoring. And even though this section is solving quadratic equations by factoring, it's usually what you would try first when given a quadratic equation. Again, I'm going to try to keep my x squared positive just because that makes factoring a lot easier. So I'm going to move the 5x and the 2 to the other side. Okay, so 3x squared minus 5x minus 2 equals 5x minus 5x, none are left. 2 minus 2, none are left, so that's why our right-hand side equals 0. To solve this by factoring, since the leading coefficient is bigger than 1, you would use the AC method, the bottoms up / slip and slide method, or the X method. I'm going to solve this one by using the X method. So to start off, I multiply 3 times negative 2 to get negative 6. The middle term, or the b value, goes on the bottom. So now I'm looking for two numbers that multiply to negative 6 but add to negative 5. So you can go through the numbers that multiply to negative 6. So we have 1 and negative 6, negative 1 and 6, negative 2 and 3, 2 and negative 3. And you're looking for the pair that adds to negative 5. So I'm going to put negative 6 and 1. And then we divide by the number that was out in front. So we're going to divide both of these by 3 and reduce as much as possible. Negative 6 divided by 3, if we take a 3 out of both, we're left with 2 over 1. And remember that the way this method works is that the number in the denominator becomes the coefficient of x, and the number in the numerator is what's being added or subtracted to x. And then for the second pair, it would be 3x plus 1 equals 0. So now that we have it factored, we're not done. The instructions say solve. So now what we'll do is we'll set each factor equal to 0. So we have x minus 2 equals 0 and 3x plus 1 equals 0. For the first, we add 2 to both sides. And then for the second, we subtract 1. We have 3x equals negative 1, and then we divide by 3 to get x is equal to negative 1/3. Okay, so in this case, x is equal to 2 and negative 1/3. So we have our two answers, and it's okay that our answer is a fraction. solve for x. So negative 30x minus 25 equals 9x squared. Again, I keep my x squared positive. So I'm going to move over the 30x and the 25. So plus 30x plus 25 plus 30x plus 25. So we have 0 is equal to 9x squared plus 30x plus 25. If you prefer to see this as 9x squared plus 30x plus 25, you can do that as well. Since there's the equal sign, you can flip the sides. Okay, so this one, if we are trying to solve by factoring, whatever method you use, whether it's the AC bottoms up or the X method, you would have to multiply 9 by 25, which remember gives us big numbers, which is usually our hint to look for perfect squares. 9x squared is a perfect square and 25 is a perfect square. So we'll make a guess and we'll build our factors based on that information. The square root of 9x squared is 3x and the square root of 25 is 5. And now we decide if the sign in between is positive or negative. We're multiplying to 25, which means we could have two positives or two negatives. But since we're adding to 30x, both of these need to be positive. Okay, notice this is the same factor twice. So you're setting 3x plus 5 equal to 0 and 3x plus 5 equal to 0. So really, we're going to get one number as our answer. So we subtract 3 from both sides, divide by 5, so x is equal to negative 3 over 5. Okay, and it's okay to get one answer. Like when you have duplicate factors like this, you'll get one answer from those. Next, solve for x. So on the left-hand side, we have x minus 2 squared, and on the right, we have 2x squared minus 13x plus 22. Our goal is to get everything out of parentheses so that we can see what we have. When we have x minus 2 squared, this means x minus 2 times x minus 2. X minus 2 is our base, squared is the exponent. It tells us how many times to multiply the base by itself. So for instance, this is not x squared minus 4 or plus 4. Okay? We have to multiply it out. So we would do x times x times negative 2, negative 2 times x, and then negative 2 times negative 2, which gives us x squared minus 4x, plus 4. Very different than x squared minus 4 or x squared plus 4. Okay, so since we just found out that x minus 2 squared is x squared minus 4x plus 4, I'm going to insert that into our equation. Okay, again, I keep my x squared positive, so when deciding whether to move the 2x squared to the left or the x squared to the right, I'm going to look at which one keeps my x squared positive, and that would be by moving everything from the left-hand side to the right-hand side. So we subtract x squared. I highly recommend lining up your terms so that way when you go to see what you have, you can just combine like terms. So on the left, everything cancels. X squared minus x squared, negative 4x plus 4x, and 4 and negative 4. So we have 0 is equal to x squared minus 9x plus 18. So now we factor. In this case, a is equal to 1. So we're looking for two numbers that multiply to 18 and add to negative 9. In this case, the two numbers are x minus 6, x minus 3 equal to 0. And you would set each of those factors now equal to 0 to find the values of x. So we have x minus 6 equals 0, x minus 3 equals 0, add 6, add 3. So our two answers are x equals 6 and x equals 3. Next, solving what are called roots of a product of polynomials, which means we have two polynomials being multiplied together. Okay, so in this case, with 2x minus 12, this is a linear factor where x is only to power 1. You can factor out the 2, the greatest common factor from this one, But for solving, that's not important. You can right away set 2x minus 12 equal to 0, but what we do need to factor is the quadratic, x squared plus 3x plus 2. So we're looking for two numbers that multiply to give us 2 and add to give us 3. In that case, it would be 2 and 1. So we have x plus 2, x plus 1. And this is, if you want to take out the 2, you can, and I'll show you what happens with it. Okay, so now we're solving for x, so the only factors or the only things that we set equal to 0 are things involving x. So that means that we'll set x minus 6, x plus 2, and x plus 1 equal to 0. The 2 doesn't have an x to it. In fact, we could divide both sides by 2 and just get rid of it. Okay, 0 divided by 2 is still 0, and then you're left with your factors only. So we're setting x minus 6 equal to 0, x plus 2 equal to 0, and x plus 1 equal to 0, which would leave us with x equals 6, negative 2, negative 1. One thing I'll mention is that if you didn't take out the greatest common factor of 2x minus 12 and just set it equal to 0, you would end up with 6 as well. So 2x equals 12 divided by 2. So you would still get x equals 6. I just wanted to show you what happens if you do take out the GCF of that factor. Thank you for watching. If you have any other questions, please feel free to reach out to me.